Howdy. Over the last 170 million plus years, life has thrived throughout the seas of planet M again, but there's a massive expanse of uncovered land still to be used all over the terrestrial tectonic plates. Relative to the sea, this is actually a pretty inhospitable place, mainly due to desiccation from unfiltered sunlight and having to find water to drink. But nothing lives here, so no competition, no predators. It's so enticing to evolution. The intertidal zone, it's one way life comes onto land, is the only way sessile organisms like the cyanophytes can come onto land. The intertidal zone is the area on the edge of all land masses, the area between the high and low tide where there is intermittently water allowing organisms to gradually get used to life on land. And here's where I admit failure. Okay, so when I originally made the project and was made part 1 all those months ago, like nearly 9 months ago now. Yeah, wait, that's 9 months old now. Like, it's the 16th. That was 9 months ago. What the hell? But basically, I decided to have the only major moon be relatively small and far away in order to create a low intertidal zone, in spite of the fact that the intertidal zone on Earth already is barely enough. So, to account for this, I'm going to retcon the moon to be a bit bigger and significantly closer to the planet. Well, probably a good bit bigger, still, smaller than the Earth's moon, but, bit closer than the Earth's moon, like, roughly a meter high intertidal zone, all the same. I don't know. And since there's no real predators, some Villae plantae might specialize for life here. As there is no more shallow water here, the monarch won't be able to float and will be more or less just a wire, hooking all the leaves together, and to avoid desiccation, they will evolve a tough outer cuticle. To let out CO2, they will evolve opening and closing sections on the cuticle. You know what I mean? I'm bad at words, okay? I'll call this clade Plantae terram, or land plants, as opposed to Mare plantis, or sea plants. Yeah, needless to say, these two names were made at different times. Another common adaptation is wood. Wood loses less water slower and more quickly transfers water from their root system, so some Plantae terram may evolve wood. And then they will push inland, where they will need to find a way to reproduce on land, seeing as simply broadcast spawning in the air will lead to the gametes quickly landing and desiccating. The female gametes may be withheld till the male gametes reach the gametangia. It'll be this way, since male gametes are less expensive to mass produce and weigh less, so will fall somewhat lower. Oh, and in case you didn't know, having fertilization happen in the gametangia makes it more likely that actual fertilization will happen. It's a big mess. Like, brain can't think of reason there, but brain can't put into words. Blah, don't have in script. Blah. I believe it has something to do with the gametes that are withheld inside the gametangia having way more time to actually meet other gametes than if they were just released into the air. I'm gonna go name the clade now, okay? I'll call this clade lignum plantae, or wood plants, as opposed to mollis plantae, or soft plants. And another, more well-known advantage of wood is that it's highly rigid, allowing plants to grow very large. As the wood is only on the monarch may form a roughly 10-meter tall pillar with leaves attached to the side of the structure. And these organisms will have the male gametangia at the top and the female gametangia at the bottom to maximize the chances of a successful fertilization. And the spore will be released from the top to minimize the potential competition with the parent colony. I.e., this is to minimize the chances of related monarchs competing with each other, and it's also to maximize the chances of leaves reaching other monarchs. I'll call these organisms Primae arboris, or the first trees, as opposed to Pudicae plantae, or bush plants. Also, unlike other organisms like, say, the octodentes, feel free to refer to these as trees, since there's so many disparately related organisms we refer to as trees in the real world, so these might as well also be trees. But other forms of Plantae terram may evolve other ways to deal with desiccation, i.e. to move the monarch underground and have only the leaves come above the ground, looking similar to ferns on Earth, since they need to let wind through without tearing them. And another development is that the monarch will develop the ability to split and branch, similar to trees on Earth. And its genitalia being so close to the ground, and other colonies being rather far away, their gametes may be moved between colonies by a network of microorganisms, and the spores will be released by Prome arboris in exchange for nutrients, similar to a fungal internet on Earth. And they probably trade other stuff as well. I'll call this clade subplantis, or underground plants, as opposed to superficies plantae, or surface plants. In the history of terrestrial life, some of these bacteria may evolve into multicellular organisms with a central bulb and hundreds of individual threads spanning their network, which both connect and trade with other organisms and absorb nutrients from the soil. To organize the flow of resources such as foreign sex cells, this bulb may contain a central ganglion to direct the flow of traffic. And these organisms may use chemical indicators such as the presence of sulfur to detect dead corpses and grow their threads into them, thus serving as the ecosystem's decomposers. I'll call this kingdom Cordis terram, or ground strings, which are clade of Duplici cerebrum. And eventually, rafting events will take this entire ecosystem all around the planet, blowing up all of the continents, making the planet look honestly a bit like an inland sea, not an inland sea, like a water world from outer space. It's gonna keep away corporations that want to make a big, cheap a cheap licensed film based on it, because they'll be scared of losing a bunch of money like Waterworld or some shit. For context, Waterworld's a movie famous for having lost the people that made it a ton of money. All these plants and the corresponding Lithonians will turn lots of rock into loose soil, releasing tons of nutrients into the water, which will fuel huge blooms of algae, which in turn will feed huge blooms of zooplankton, which will use up all the oxygen in the water, killing everything in the area. Or, more commonly, using up most of the oxygen, killing most large or complex things. This is one of the possible causes of the Ordovician Silurian mass extinction event, and it may also come in multiple waves as terrestrial organisms reach new areas. In addition, I believe this is pretty much inevitable if life comes on land. And if you want to learn more about this, then I suggest you go watch this PBS Eons video linked in the description about how pretty much this may or may not have happened on Earth at the Ordovician Silurian mass extinction. And yes, I am not happy that this video is apparently 2 years old. Seriously, what the fuck happened to March 2020? Although this is a very severe mass extinction, its effects are very evenly spread out to the point where very few clades diverse enough to have been denoted in this series will be lost in their entirety, but almost all will lose significant diversity. Massive filter feeders like Gigantes autumn superficium will starve to death, in addition to suffocating, and so Tres Nevis Calvariae locus will follow suit, and most Dente membrana piscis will have their population driven so low that, while they themselves survive, their predators will not, and so thus marks the end of Tres Nevis Calvariae locus altogether. And so the population of Dente membrana piscis will boom, and so there will be no more food, and that process will wipe out the species in most areas, though the overall clade will survive and return to these areas. And in the reefs, much diversity may be lost, particularly Cura metella fodinum and Impetum forbus, although the latter won't be gone entirely and will recover. And further down in the benthic zone, Lumis luctu ocoli won't get enough food to support its large size, and the local Stellaqui fugit population, and of course the predators that survive upon that, will also struggle. So with all that said, now we have a pretty full view of the extinction log, leaving many niches up for the taking, which I will refill in the coming episodes. So, as mentioned before, Lumis luctu ocoli is gone, leaving open the niche of benthic scavenger. And these new forms may convergently evolve similar features for the same lifestyle, for instance, large size to keep in heat, and subcarangiform locomotion. And Lumis luctu ocoli gets its namesake from its bioluminescent eyes, which it uses to see in this horribly dark environment. But this new clade might find a completely different solution to this problem that doesn't involve sight at all. They may evolve sound-sensitive hairs on the other side of their teeth to pick up on sound vibrations to find the general direction a carcass is in, and big eyes to figure out the details. I'll call this clade Totus circa dentes meos or hairy teeth as opposed to Calvitium circa dentes meos or bald teeth. Also, for some reason, I wasn't fully confident in the name of the latter one, but if it's broken Latin, then that just means it's more distinct, so In the reefs, Colopilisae is gone, but Impetum forbus survived. The difference between the two, as in one surviving and the other dying, is Colopilisae has its entire breathing surface a good foot underground most of the time. Whereas Impetum forbus has multiple gills near the surface, so Colopilisae is particularly vulnerable to changes in the oxygen level compared to Impetum forbus. So, yeah, that's gone now, and in its place, new predators will evolve to fill the ecological niches of predators in the reefs around the Great Western landmass, and they may hunt in a very different way to how the reefs have traditionally been hunted in. Some of the local cecilivores may begin hunting smaller motel species before adapting to bigger ones. As they adapt to this lifestyle, Molus russuspecius may hide in reefs' crevices, waiting to lunge out at prey. While Brachium expandant natans may chase prey through the reefs, and Dim oculus mays may chase prey into the open water to be caught. I will refer to all of these organisms as the predatory reef-dwelling variants of whatever clade they're from, and around Para Britannia and Para Ireland, Impetum forbus simply survived and recovered, so no need to create new clades there. Further up in the pelagic zone, the main surviving motile animals are Dente membrana piscius, and so they will take up the niches of pelagic filter feeders and macropredators with their unique contingencies regarding their teeth. Okay, I admittedly wrote the last bit way back when Dente membrana piscius had a way more convoluted tooth setup, which I wasn't sure of, so I left this blank to deal with later. Well, now it's May 2022, and this is like 2 episodes from the newest released one, so, gotta deal with this now. There's a clade that evolved to filter feed by holding their mouth membrane wide open as they swim forward in order to capture plankton. I'll call this clade Rete oris or net mouth as opposed to Capinentes oris or capture mouth. And another clade adapted into large macropredators, unlike Tres nevis calvaria locus, which used its giant open teeth to stab into prey and let them bleed out and die before actually catching the prey. These forms may instead bite on and use suction pressure from their membrane to hold on like a parasite, ruining their prey's hydrodynamics and letting them get exhausted from trying to escape. Before taking large chunky bites of their prey alive, the bleeding from these wounds killing them as they are consumed, or at least that's how they kill the filter feeders. Yeah, this is gonna be interesting to draw. Like I just described the way some predators kill their prey in rather graphic detail, so that's gonna be fun to draw. No joke, I do seriously think it's gonna be interesting. They both catch Capientes oris by grabbing them and crushing them with the ends of their teeth. I'll call this clade Harana membrana dentes meos or clinging membrane teeth as opposed to Capere bucca or capture jaw. So, fresh water. In addition to wreaking havoc on the oceans, the terrestrial cyanophytes will create a whole new aquatic environment inland, turning swamp and mud into rivers and lakes. By giving the surrounding soil/mud rigidity with their symbiotic Lithonian roots and providing a food source along with the loner plantae that move in. But you see, not all areas of fresh water are very reachable. Okay, so imagine that. Okay, so organisms can't just go anywhere. As I said a moment ago, organisms can't just go anywhere in the rivers they want. So imagine that this is the ocean. Okay, here. Okay, and then I draw this. Hopefully you can't see that. Yep, this is the land. This yellow stuff's the land, and then this is a single river. Now, as you can see, the edge of the line go very strongly along the river. Stop! I bet it's doing some stupid shit whenever I try to go down from the top. Damn. Okay, but as you can see, there's a river here. Organisms can obviously just swim from the sea up into the river, right? Like, they can just do that, right? Okay. Let's say here I put this little black dot representing a waterfall. And it's not like water sliding down a cliff, it's like water goes off a cliff. There's a cave on the other side, behind the waterfall, Nothing, organisms can't just go up it. So on this top area up here, or on this bit, you won't find organisms that live at the bottom. However, there's an exception to this. If there's another stream that goes around like this, and it's assumed that all this is going up altitude, then organisms could go around this way, and then they could be at the top of the waterfall. And similar principle goes for lakes. Theoretically, organisms couldn't just get into a lake like this, but at least at some point, the lake was probably connected to some stream, and so what organisms could get in there before it was then cut off, assuming it is cut off currently. And that's ignoring all sorts of various amphibious organisms that may exist. But I digress. Many Plantaiterum species may inhabit the lakes and rivers on the great western land mass and the eastern continents, which they will reach in the same sweepstakes colonization event as the fully terrestrial cyanophytes. And so these forms will serve as a food source for freshwater Captorcirca dentes meos, since their methods of swimming are good for navigating the winding river systems of the world, and they're already the default large plant eaters. These forms will look like just about any other Captorcirca dentes meos, they're a pretty homogeneous phylum. But to see through the murky river/lake water, these ones will often have adaptations to electroreception and infrared vision achieved through Earth-like methods. Many organisms may also use echolocation, but Captorcirca dentes meos won't due to anatomical challenges. Other species may evolve to bottom feed. For instance, on Para Ireland, a clade of Odysseus squammis may use their front limbs to dig around for food in the form of detritus and small Stelaque fugit. And to do this, they may adapt their front limbs into a spade-like shape to dig through the sand and soil at the bottom of these bodies of water, and their walking legs may thicken to better clamber over the rocky terrain. I'll call this clade Retrum manus, or shovel hands, as opposed to Acuta manus, or sharp hands. On Para Britannia, the same niche is filled by Stelaque fugit. These species have a cartilaginous internal skeleton in their legs to clamber over hard and/or steep and/or slippery surfaces. And the setae on their arms may fuse into dedicated spades used to dig for food, but not before significantly more of them grow to make it easier to detect things in the murky water, all called as clade. Os crus astra, or bone leg stars, as opposed to mollis crus astra, or soft leg stars. Editing side note here. Okay, fine. These assets are inaccurate. First, I drew them with hair, ignoring that they have spades. Then I drew over the hair as spades, getting rid of the hair technically, but you can still see the hair, so fuck it. It's been 4 months. I can't be bothered to redraw this asset all over again, let alone wait for the day not to be rainy, so I can get a good photo of it with outdoor lighting coming in. It's like, fuck it. It's taken 4 months to get this video out. I want to get the fuck over with, okay? Meanwhile, over on the northern landmass, this niche is filled by Acuta manus, and these forms show the same adaptations as Retrum manus, making them look very similar, in spite of living on the other side of the world, give or take. I'll call this clade parallel vermes or parallel worms, as opposed to ipse vermes or unrelated worms. And on the great western landmass, this niche is filled by Curomatella faudiensure. These forms use their thick muscular legs to handle difficult surfaces, and the same muscular legs to dig through sediment. I'll call this clade Cura musculus, or muscle legs, as opposed to Cura remisa, or slack legs. Okay, so look, I'm not happy with most of the script I have. I can't be bothered to go to all the trouble of reading out a script. I don't really feel like writing new stuff out since I'm not sure what to put. But on the other hand, I have to have predators in the freshwater ecosystem, so here's what you're getting. Just an off-script bit. So I know for Para Britannia I wrote this clade of Vignae gardens et foribus, which basically have venom, which they make in glands evolved from salivary glands, and they inject it through teeth which have tunnels in them for that venom to travel through, which makes their teeth more fragile. That's why I gave them the name Dentes fragiles mortis, or brittle teeth of death. And of course, I didn't create a name for the counterclade. And do I feel bothered enough to? Will I do it in editing? Will I do it in retrospect sometime? I don't know. I can't be bothered. On the other hand, the inconsistency is pissing me off. Ugh. For para, what's it? For what continent is this? I think it's for para Ireland. Basically, I wrote something where like last year where it's like, huh, now there's a lot of animals in freshwater that have like big mouths and just swallow their prey whole. I should reference that trend. And it's like, one, I can't remember the animals I was going off of at the time right now, except for like catfish, and also it's like, I don't know why it would happen. On the other hand, I'd rather they do something somewhat interesting, so fuck it. Big octodentes that swallow their prey whole in the rivers and lakes of Para Ireland. And then on the Great Western Landmass, what did I have? Okay, so it seems to be an Everclade of animals that just got really big. In this case, it's like just having really small. What even is this? Something about like size relative to river problem. It's this one saying that the other one must have had something about like problems with like size relative to river, or something in terms of its solution that I wrote it. Yep, this off-script bit is very low quality. Look, I had to have predators in these ecosystems to have this video finished, and I want to get this video over with because I'm tired of working on it. Its theme isn't really that interesting to me. Like, literally the next proper video is like literally like the first clade of radial zones coming onto land, and what's this? Some like a whole bunch of the same like basically a whole bunch of filler. The last bit was like multiple of the terrestrial body plans are based on the animals I showed in the previous scripted bit, but like this it's like I don't really care about it. God, I hope these mouth noises aren't getting into the audio. I can hear them as I talk, so hopefully they're not getting into the audio. Fucking hell, I've been going for so long with this. I called the ones living in Para Ireland behemoth piscis or behemoth fish as opposed to pisciculus or small fish. Yeah, I think Google Translate fucked something up there. Those are supposed to be two separate words, not one. Fuck it. I really don't want to be making this section. It really doesn't add much. So why am I dragging it out? I bet it's like half the video now. Yeah, so I guess this is I'm recording this outro right after recording the outro for the previous season episode, but yeah, you can tell. Yeah, again it didn't take very long to make this season episode. It was like a not even a 15-minute editing job this time. It was more like a 5-minute long editing job because I've gotten better and better at editing these over time. But yeah, looking at the video length, like the original season episode was like the well, not last season episode, not the original season episode, but like the PENH Part 4 season episode was like 15 minutes long, and this is like 23 minutes long, which is like I think that's very reflective of what the part is because like the part this in terms of content, this is basically most of part 5 is just remaking the stuff that was destroyed in the mass extinction episode, and basically it's so from that angle it can be thought of as part 3 plus the stuff about land plants plus the like 2-minute discussion of mass extinctions plus the freshwater stuff minus the stuff that survived the mass extinction. So it's about the same amount of stuff plus a little more, and so the length it's kind of reflective of that, which I think is interesting. The production of this was interesting. It went quite well for quite a while. It was going fast. It was going well. Everything seemed to be looking up. Then I took a break to work on part 1 redone, and so that happened. Then I just completely lost all motivation, even more than last time when I was slogging through the production of the final part of part 5, and so that came out like 6 months after. Not 6 months. What was it? It was almost 6 months after the stupid thing started. And then, yeah. So that all happened, and then there was I went on hiatus for months because of some weird bureaucratic bullshit with some like basically technical stuff behind the scenes, basically prevented more content from being produced for months. But yeah, that's a whole thing. But yeah, anyway, so that's this season episode out. Part Five's production went relatively well. There was very few hiccups outside of the final episode. So yeah, bye people.